on Monday as we did the synthetic division. Does anybody want me to go back over that just as a refresher really quickly? Yes. Okay. So if we do these, I'm going to take this 2. We always do the opposite sign, so since it's negative, I'm doing positive. I check here, I go 3, 2, 1, none, so I'm in order. So I write those numbers down. Draw my line. Bring down my 3. And then I multiply. 2 times 3 is 6. This is synthetic long division. It is, so once you've got your 6, you're adding down. So negative 8 plus 6 is negative 2. And then I multiply. 2 times negative 2 is negative 4. 11 plus negative 4 is 7. 2 times 7 is 14. Negative 14 plus 14 is 0. This is my remainder. So I have no remainder, which is good. That means it divides evenly.
What's the 3, 2, 1, and 1?
Exponents 3, 2, 1, none. And so you have to have, so I have to have, like here I have 4, 3, I need a 2, and then a 1, and then a none. You have to have, from your highest exponent, you have to have every exponent as we move down. Now, so I'm finished with the division. These numbers here are my new coefficients. Okay, so I start with 3, x. My highest exponent was 3, so now it's a 2. I'm always one exponent down from my highest exponent. Minus 2x plus 7. So on this next one, see how I have 4, 3, but I'm missing a 2? So I have to put in like a 0 b squared. Because you have to have a placeholder. You have to have every exponent all the way down in order. And then I have 4, 3, 2, 1, none. So that's good. I have a minus 2 again, so I put a positive 2 here. It's always the opposite sign. 6, negative 8, 0, 12, and negative 14. Because that 0 is for that b squared that didn't exist. But I have to have it, a place for it. Yes. Okay. Questions about just this initial part of the setup? That part's okay? Bring down the 6. Multiply everything here by 2. So 2 times 6 is 12. I'm going to add straight down. So negative 8 plus 12 is 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. 12 plus 16 is 28. 2 times 28 is 56. So I have a remainder of 42. And then just, that's what we're bringing up, the multiplication. So because I have a remainder, this one's going to look a little different. What I do is these are still my new coefficients. So I start with that 6. I was b to the 4th, so now I'm b to the 3rd. My plus 4b squared plus 8b plus 28. And then for that remainder, the remainder goes up here. And then this is the, is that divisor or dividend? Oh, darn it. All right, it's the divisor. Okay, so that's this part right here that goes there. So if you have a remainder, it just looks like this. You make a fraction out of it. Synthetic division works best when there's no coefficient on this x here, or b, or whatever letter this is, when there's no number on that part. Here's why. If I have a divisor, or not divisor, I'm sorry, coefficient right here on the divisor, I can't use synthetic division the way it is. I have to divide everything by this number, so I have to divide everything by 3. And now you can see I'm working with x to the 4th minus 5/3 x to the 3rd plus 1/3 x squared plus 7/3 x plus 0, because I have to have that placeholder for the no variable part, divided by x plus 1/3. And I have to do that because I cannot have a coefficient here on the synthetic division. So as you can see, when you have that coefficient, synthetic division can become somewhat unattractive. So I'm going to show you how to do this with the synthetic division, and then I'm going to show you what it would look like with the normal long division so you can decide which one you like best. Okay, so this was positive, so I have to put it in negative, and then I have 1, negative 5/3, 1/3, 7/3, and 0. I'm going to bring down that 1. Negative 1/3 times 1 is negative 1/3. Okay, negative 5/3 minus 1/3 is negative 6/3. But negative 6/3 is 2. Negative 2, sorry. So I'm going to do negative 1/3 times negative 2, and I'm going to get positive 2/3. And 1/3 plus 2/3 is 3/3, which equals 1. I'm going to do negative 1/3 times 1, so I'm going to get negative 1/3. 7/3 minus 1/3 is 6/3, which equals 2. And negative 1/3 times 2 is negative 2/3, and that's my remainder. So I had all these fractions I had to deal with. Now, this will give me x to the 3rd minus 2x squared plus x plus 2 minus 2/3 over x plus 1, but I can't have a fraction inside of a fraction. And so I have to bring this denominator down here. And so it gives me x to the 3rd minus 2x squared plus x plus 2 minus 2 over 3x plus 3. So that's with synthetic division if you have this coefficient right here. We're going to kind of ignore this, and I'm going to do the long division. If I had done it with long division, I still need that placeholder for the no x. To turn a 3x into a 3x to the 4th, I'm going to multiply by x to the 3rd. So x to the 3rd times 3x is 3x to the 4th. X to the 3rd times 1 is x to the 3rd. Subtract that. Those will cancel. Negative 5 minus 1 is negative 6. Bring this down. To turn 3x into 6x to the 3rd, negative, I'm going to multiply by negative 2x squared. So negative 2x squared times 3x is negative 6x to the 3rd. Negative 2x squared times 1 is negative 2x squared. I have to subtract that. Negative of a negative is positive, so that becomes 3x squared, and I bring down this 7x. To To turn a 3x into a 3x squared, I multiply it times x. And I get 3x squared plus x, which I subtract. Sorry, this is getting so small. Multiply that by 2. And I get 6x plus 2. And when I subtract this, I get negative 2. That's my remainder. So this is minus 2 over 3x plus 3. Same answer, no fractions. So what we have are the types of polynomials you have. You can have what's called a constant polynomial, and that's a polynomial with no variable. It's just a number. A number is called constant because it's constantly whatever number it is. It doesn't change. The degree of a constant is 0. That's because there are no exponents on variables, so 0. And the leading coefficient is just the constant. A linear polynomial has a variable with no exponent. So the degree is 1. And the leading coefficient is the number on the variable. Quadratics have an exponent of 2. So the degree is 2. That leading coefficient would be 5. A cubic has a degree of 3. So the degree is always the highest exponent, and the leading coefficient is always the coefficient on the variable with the highest exponent. Now, the general form of a polynomial is a sub n, x to the n, plus, and then you have n minus 1, n minus 1, n minus 2, n minus 3, n minus 4, all the way till you get down to 1, and then none. So it's like this. 10, if we start with 10, you have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, none. You always go down by one exponent. Now, if you were missing something, like let's say this x to the 6th wasn't there, then there's like a 0 as your coefficient. So whatever your degree is, it's that highest exponent. And then your leading coefficient is whatever coefficient is on the highest exponent. I didn't define this. A polynomial in one variable is just it's not, if it has more than one variable, it's not a polynomial in one variable. That makes sense, right? And the leading coefficient of each polynomial in one variable. And if it's not a polynomial in one variable, we need to explain why. Okay, so we first look through and see, okay, is there only one variable? Let's see, there's just x is cool. It's a polynomial in one variable. The highest exponent is right there, 5. So the degree is 5. And the leading coefficient is 8. If I look at this second example, I have an xy, so it's not a polynomial in one variable. Because it has 2 letters. Leading coefficient. Right here, leading coefficient. Now, if I look at these, I've got one variable. So I find the highest exponent. It's not always in front. So my degree here is 8. And my leading coefficient is negative 4. Even though it was not up at front, it's still, because it's on the highest exponent, it's still the leading coefficient. The other thing, see how this x here is in the denominator? This is not a monomial. So this does not qualify as a polynomial. So you can't tell the degree or the leading coefficient. But you should be able to do 2 and 3. So I'd like.
I think 3 is 6,
Uh-huh.
and then leading coefficient is 5.
Perfect. And how about 3?
Degree is 6.
Uh-huh.
Leading coefficient is -1.
Perfect. A polynomial function is any continuous function that is described by a polynomial equation. So f of x is equal to 3x to the third minus 4x plus 6. It could be really anything over here, as long as it's continuous. And if it's a function, it's not going to have any square roots in it. It's not going to have any variables in the denominator. It's not going to have the two variables multiplied together. So basically all those things we said it can't have, it's not going to have. Right. A power function is the simplest kind of polynomial function. And it's just f of x is equal to some letter, like x, but some number and some exponent. And there's nothing added or subtracted. It's just like 5x to the 10th and it's done. Something like that. Or, you know, like negative 2x to the 4th. Oops. I should put the f of x in front. So we're going to evaluate a function. Evaluating just means to plug in given values and simplify. Okay, so if I have this equation, the volume of air in the lungs during a 5-second respiratory cycle, so breathing in and breathing out, can be modeled by this equation, where V is the volume and T is the time in seconds. Okay, so we have this equation, V is the volume in liters in, whatever, and T is the time in seconds. So we want to find the volume of air in your lungs 2 seconds into the cycle. 2 seconds is T. So I'm going to take this equation and I'm going to replace all the T's with 2. Okay. Then I'm going to do the exponents. So 2 to the third is 8. 2 squared is 4. Well, this one doesn't have an exponent. Then I'm going to do the multiplication. So I have 0.037 times 8 0.152 times 4 and then 0.17 times 2. Then I'll add everything. So at 2 seconds mark, you have 0.652 liters, so just over half a liter of air in your lungs. Good catch. Thank you. Which will change actually this number, 0.0173 times 2 3, 4, 6, which will change that to an 8. So it's 0.658 instead of 652. Thanks for catching that. Now, you can do evaluation where we plug in a number, or you can do evaluations where we plug in other things and we can change the functions essentially. So, so f of x is 3x squared minus 4x plus 12, but I want to know what's f of 2y. What I need to do is I'm going to replace x with 2y and simplify. So whatever is inside this parenthesis replaces all of these x's. So we're going to do, okay, so I had 3x squared, so now that's 3 times 2y squared. Minus 4x, so it's 4 times 2y plus 12. So that's 3 times, if 2y squared is going to be, so I have to square both the 2 and the y, like that. So I get 4y squared, and then 4 times 2y is 8y plus 12, and then 3 times 4y squared is 12y squared minus 8y plus 12. So that's what f of 2y would equal. Here I have something happening on the outside. So you have negative 6 f of b. So on this one I have to do two things. I need to replace x with b, because the b is in the parentheses. And then I have to multiply everything by negative 6. Because that negative 6 is saying negative 6 times f of b. So there's two things happening here. What's happening in the parentheses is replacing the x. What's happening outside the parentheses is happening to the whole function. So negative 6 f of b. I'm going to do negative 6 times. Every x is going to be replaced by a b. So this x, that x. And then I have to multiply it all by negative 6. So it's an 18b squared minus 30b minus 60. Okay, so this one is one of the most complicated you'll get. Will be like this. And there's a couple different things going on. I have f of 3c minus 4 minus 5f of c. So I actually have two parts happening here. And I'm going to do this part in red, and I'm going to do this part in blue. So hopefully that'll help. Okay. So in the first part, I'm replacing x with 3c minus 4. In the second part, I'm replacing x with c, and I multiply everything by negative 5. Okay, because as you see here, there's a c there, but there's negative 5 on the outside. So I have two different things happening. So in this first part, I'm replacing x with 3c minus 4. So it was x squared, so now it's 3c minus 4 squared. it was 2x, so now it's 2 times 3c minus 4. And then that plus 3 just gets to hang out. For the second part, I have to multiply everything by 5 and replace the x's with just c. So x squared becomes c squared, 2x becomes 2c, and then that plus 3 stays the same. Now that I have the replacements, I have to actually do the simplification. So I'm going to FOIL, that's right, 2x. So it became 2, 3c minus 4. Is that, okay. So I have to FOIL this. Which I will do up here. Okay, so 3c times 3c, which is 9c squared. 3c times 4, so that's negative 12c. Yeah. And then 16. Sorry, that's a 16. So it's first, outside, inside, last. So I get 9c squared minus 24c plus 16. That's a 16 right there. So that is what is just this portion. Okay. Then I have to distribute this 2. So that gives me 6 plus 6c minus 8, and then that plus 3 is still just hanging out. 12c plus 16. So now I also have to distribute this negative 5 times everything, because everything had to be multiplied by negative 5. So that gives me negative 5c squared minus 10c minus 15. Once you've done the multiplication, then we have to collect our like terms. Okay. So I'm going to label those with color. I have 9c squared and 5c squared. Those are both my c squareds. So 9c minus 5c squared is 4c squared. And then I have negative 24c, positive 6c, and negative 10c. So negative 24 plus 6 is negative 18, minus 10 is negative 28. And then I have 16, negative 8, positive 3, and negative 15 that are all the same. So 16 minus 8 is 8, plus 3 is 11, minus 15 is negative 4. We have the basic shape of the different polynomial function graphs. Okay, so a constant function, degree 0, this is like f of x equals some number. Well, c. Let's see. So it's just f of x equals like 5, f of x equals negative 2, something like that, and you get a straight horizontal line at that number on the y-axis. A linear function is degree 1. This is, every time I say f of x, that's the same thing as y. So this is something that you were used to, like y equals 2x minus 4 or something like that. Okay, that's a straight line linear function. Quadratics are degree 2, and that's the parabolas that we did the graphing on. This one happens to be negative. I don't know if this is the correct graph for it or anything. It's just an example of what that would look like. Cubics happen when you have x to the third. Quartics x to the fourth, quintix, x to the fifth, etc. Now, if you look at this quadratic, it's a degree 2, right? X squared. I have 1, 2 parts. Do you see that? It's kind of like got 2 parts. This part on this side and this part on this side. And a cubic has 1, 2, 3 parts. Quartic has 1, 2, 3, 4. Quintic has 1, 2, 3, 4, 5. Do you see that? So that'll kind of help you to, if you look at a picture, you can kind of say, oh, that's, the degree will be this many because I have 1, 2, 3, 4, 5. Okay. The domain of all of these functions will always be all real numbers. You can do the symbol for it. The range is what will change. The range will be y greater than or less than maximums or minimums. Or it will be all real numbers. Okay. End behavior, you'll need to understand what this means. End behavior is what happens to the graph as x approaches infinity, which is symbolized like this, and negative infinity. Which is symbolized like that. Okay, so end behavior occurs out these ways. So as you can see here, this end behavior, as x approaches infinity, we're going up. As x approaches negative infinity, we're going down. So that's what's happening at the ends of the graph in behavior. What to look for? So let's look at this. All right, so what we have is an even degree. So this is even exponents, right? With a positive leading coefficient. So like x squared. Or if we come back here, this is x to the fourth, but this is positive. What will happen is as the graph approaches, okay, so sorry, I'm going to go as x approaches infinity. So this is infinity here. Y also approaches infinity. And as x approaches negative infinity, that's over on this side, y approaches infinity. So as we go left and right in infinite directions, we continue to go up. Do you see that?
Is this the math term for infinity?
Mobius strips are cool. All right, so our domain, all reals. As a matter of fact, we can just go ahead and write that down for all of them because the domain is always going to be all real numbers on these. Now our range, as you can see here, range is y's. Domain is x's, range is y's. We don't go down any further than the lowest point on the loop. So your range is going to be y is greater than or equal to the minimum. And that's wherever this hits. Like in this case, it's 0, but it might be up here. It could be down here. It's wherever that lowest y is. Okay, so that's with an even that's positive. If we have an even that's negative, it's almost the same, except instead of approaching infinity, we're approaching negative infinity because we're upside down. Okay. So the x will still approach infinity and negative infinity, but instead of approaching infinity, we're not going up anymore, we're going down, so we're approaching negative infinity. And instead of being a minimum, we're going to have a maximum, which is the top of the loop, and will be less than or equal to that maximum value. Then we have odds. So if we have an odd, so our exponents are 1, 3, 5, 7, 9. As x approaches infinity, if it's positive, f of x approaches infinity. So they go up together, they go down together. So even functions always go up both sides or down. Odds will go up and down together if they're a positive. If they're a negative, it's backwards. As x goes to positive, y goes to negative, and as x goes to negative, y goes to positive. So if they're positive, they move together, both going to infinity or both going to negative infinity. And if it's negative, they flip-flop and go in opposite directions. Our range, well, it's going forever, right? It's going forever up and down. So if you have an odd exponent, your range is all real numbers. It's only when you have an even exponent that you have to worry about minimums and maximums. Zeros is the same thing as the word roots, which is the same thing as the word solutions. Okay? If you have an odd degree function,
Why is 0 the same order as root?
they just are different. They all mean the same thing. It's basically where the graph crosses the x-axis. So it's where y equals 0. So that's why they're called 0, and then they're roots because they're the root of the function, because they're the solutions. The words are all the same thing, really. But if you have an odd degree function, you have an odd number of zeros. Okay? So that means you're going to have 1, 3, 5, 7, etc. If you have an even degree function, you're going to have even number or no zeros. So 0, 2, 4, 6, etc. So if we look at these pictures, zeros are where we cross the x-axis. As you can see here, this is an even degree function because they're both moving in the same direction, the arrows. So that's what tells me it's even. But it never crosses the x-axis, so there are 0 zeros. This is even, but I have 1, 2, 3, 4 zeros.
Why?
Because it crosses the x-axis in four places. Odd degree polynomial, you can tell it's odd degree because the arrows are moving in opposite directions from each other.
3 0.
3 zeros. And this one has 1 0. The end behavior. So first I look at where the arrows are going, and they're both going to negative infinity. So f of x approaches negative infinity as x approaches infinity and negative infinity. So as x is going both towards infinity and negative infinity, f of x is just going towards negative infinity. So that's the end behavior. Is it even or odd? Well, both the arrows are going in the same direction. So it's an even function, even degree. And the number of real zeros. 2 real zeros because we cross the axis 2 places. Graph, I have one arrow going up and one arrow going down. So this is infinity, this is negative infinity, infinity, negative infinity. So f of x approaches negative infinity as x approaches positive infinity, right? Because on this side we're going down. And f of x approaches positive infinity as x approaches negative infinity, because over here we're going up. Because our arrows are going in 2 different directions, we're odd. Degree does not start with a G. Okay, so if your arrows are going in the same direction, you're even. If they're going in opposite directions, you're odd. And then how many zeros do we have? 1, 2, 3, 4, 5.